Okay, picking up where we left off, we're on page 144, and I was telling you the story about how through mergers and acquisitions and stuff, Time Warner ended up with a huge chunk of addresses that, quite frankly, they're not using all of them. Okay, so we needed another system. We needed a system that instead of having a 32-bit addresses, let's go to something bigger, right? Let's go to 64-bit to make it bigger. And they went, no, let's just be ludicrous about this. Let's leave ourselves so much room that we can do some additional organization. Sure, going from a 32-bit number to a 64-bit number would have solved the problem of addressing, giving out addresses. True, it would have. However, if we make it monstrously huge, like a 128-bit number, then we can throw in all sorts of cool stuff. Over and above just addressing, I can have a particular addressing scheme. Okay, so first, how big is a 128-bit number? Well, there's this cool little thing here. So this is what a 128-bit number would be. 320 unidecadillions, whatever the hell that is. Okay, so it's 340 hell of a lotas. Okay, one big ass number. Okay, did they intend to spit all these numbers out just like it is, just like the same scheme before, where you split them in half and split them in half, split them in half? Well, hell no, that's not what they intended to do. Okay, so let's talk about routers. Routers were kind of sort of designed to be able to take the old style header and the new style header. All you had to do was just make like a firmware change to the router, and then from then on, it would be backwards compatible. If I sent it an IPv4 packet, it'll take it. If I send it an IPv6, it'll say, fine, no problem. So let's look at this. So the version, this is very important, because if it's a 4, I need to go do something else. If it's 6, do this. Now there's a lot of different things in here. The traffic class, we didn't have that before. The flow label, we didn't have that. The payload length, that's cool, that we didn't have that part. The next header and the hop limit, which is kind of sort of the same thing as, in fact, it really is the same thing as the time to live. So what's missing out of this? Here's the things that are there. What's missing? What about that header checksum we talked about? It's not here, is it? Well, because by this time, we realized that in practical terms, every single one of these guys is most likely going to be inside a layer 2 header that has its own CRC checking going on. And so it was just not needed. So they dropped it. Now, the source addresses are monstrously, because they're 128, right? They didn't just double, they quadrupled the guys. Okay, source address, destination address. All right, so how do you show this thing? Since dotted notation, you know, the 192 dot whatever would be a little weird. So here's how they did it, and they did it. This is address for a particular university. This is what's so cool about having an enormous address space. I could, for example, go in and just break these things up any way I want. I'm designing an IP address that matches me. For example, let's say that this is the code for one of the buildings, or in this case, here you have campuses. So this is the Tampa campus and the St. Pete and Sarasota. And then maybe over here is the building. And maybe over here is what floor we're on. See, it's because I have, for all intents and purposes, unlimited amount of space in my addresses here. Come on, really? Come on. I can just say, well, I want a chunk of this address to be the campus, and then the building number, and then the floor, and then perhaps whatever use it is. I can just make up my own scheme. It doesn't matter. It's up to me. I'm going to be going in here, and I can make this make sense to me. That's what it was all about. Okay. And then the rest of this stuff can be just hosts. Okay, cool. They don't necessarily use numbers to do that. they use hexadecimal, and hexadecimal is more concise. It uses fewer characters to do it. If I was to say 255, that takes 3 characters to say that, right? I could say it in hexadecimal with FF. It's just physically smaller. Plus, if I have a bunch of zeros, a bunch of contiguous zeros, like I had a chunk of zeros here, a chunk of zero, I just put a colon in here, and that basically means shorten. I mean, it just means there's a bunch of zeros in this next chunk. So, this is a hexadecimal number, colon, hexadecimal number, colon, hexadecimal, colon, hexadecimal number, colon. And if those higher numbered ones aren't there, you're allowed to kind of collapse them up. Okay. Whatever. So, the cool part about IPv6 is it solved the problem with not having enough. And not having enough is complex because what it really prevented, okay, let's talk in real term. What it really prevented is an all-out war with going to companies and saying, I'm sorry, we need to take away some of your IP addresses. And that would have just been holy hell. Okay, there would have been lawsuits and screams and hollers, and everything would have just got bogged down in law. This allowed them to just deflect the entire problem completely and say, look, I know these guys over here are starving, and I know you over here have plenty of food, but we're going to ignore that, and we're going to give you a new scheme so we don't have to think about it. That was probably a pretty bad example, wasn't it? But anyway, the point is, the cool part about this is it stopped all the fighting. We didn't have to go back and reclaim any IP addresses. In fact, one of the problems with IPv4 is, let's say a company went bankrupt and they closed. The IP address range became like property of the estate, and you could buy the leftover IP address range from the previous company. In other words, it wasn't like automatically given back to the numbers and naming addressing people. It was considered property, part of the estate, and you could buy them. It's kind of weird, huh? Okay. Believe it or not, we've reached the end of the chapter of IP. Yay! And so we're going to talk a little bit more about how the actual routing takes place, because we haven't really done that here. We've talked about IP, but we haven't really talked about the mechanics of how it gets from, how do you discover how to get from here to there. That's kind of different. All right. So we'll see you guys again in some future chapter.